to today's math class on online math hub. And right in front of us we have this question for us. So this is a simple Diophantine equation, and we are just going to find we are just going to solve this equation right here where x is a prime. So that is the question in front of us, and it's just pretty simple. We are going to be doing it together. But just before we delve into solving the equation, if you are new to our channel, so kindly like this video, give this video a thumbs up, subscribe to our channel for more updates, and also turn on the notification icon so that whenever we release new content, you will actually get to know about it. And of course, you go ahead and check it out for yourself. So having done that, we're just going to proceed to solving this question right here. So once you have a problem like this, you can always start by writing your solution. Okay, and then afterwards you just write the question right here. This is equal to 4. So it is just pretty simple. We are going to write this to be x equal to 4, or rather we write this x equal to y raised to power 4 plus 4. Okay, now this is what we have, and then next we can simplify further. This is actually going to give us equal to, we can write this y raised to power 4 as y raised to power 2 or raised to power 2. Also, this is a law of indices that basically say that if you have let's say a raised to power n and it's also raised to power m, you can actually multiply the power so that you now have a raised to power m times n. So this is what we just applied right here. Let me just clean it up, and then now moving on, we can also rewrite this 4 as 2 raised to power 2. Okay, now it's looking pretty simple. And then you need to also remember that if we have a raised to power 2 plus b raised to power 2, that this can also be written as a plus b or raised to power 2 and then minus 2ab. So you need to remember this. This is what we are actually going to apply. So since we have something that looks like this one right here, we are going to transform this one to look like this. So that's what I'm going to write on the next stage. Okay, so I can rewrite this to be, this is our a plus this is our b. Okay, so our a is y raised to power 2 plus 2 bracket raised to power 2 and then minus 2 into y, that is our a raised to power 2. Okay, and then times our 2. That is what we are having. And then of course you can write this to be y raised to power 2 plus 2 minus let's say 2 raised to power or 2y all raised to power 2, because if you multiply this is actually going to give you 4. So 2 raised to power 2 is 4, and then y raised to power 2 gives us exactly what we have right here. So this is what we are having here. So let me still write this normal. Okay, now you also need to understand again, or remember again, that if you have a raised to power 2 minus b raised to power 2, this can actually be written as a plus b bracket open bracket close, and then we bracket open a minus b. So if you open this bracket, this is what you're actually going to be having. So what I'm going to do next is I'm going to, since this is appearing in this form, so I'm going to rewrite this to look like this one. Okay, so that's what I'm going to write on the next stage. So I have that this is actually going to look like a, this is our a, so our a is y squared plus 2. Okay, and then plus our b is 2y. Okay, so I open another bracket, y, that is our a, y squared plus 2, and then minus our b, and our b here is 2y. Okay, pretty simple. And then we are going to be continuing from here. So what we are going to do now is we can just transform this a little bit, and then if we do that, what we are going to be having is x, we are going to be having y plus 1. If you actually open this bracket, this is actually what you are going to be having. So if you open this bracket, because if you open this bracket, you are going to be having x squared y squared plus 2y and then plus 1. So if you now add it to this one, you get the extra 2 we have here. And then we can also do same here. This should look like y minus 1, okay, squared plus 1. So this is what we have here, and don't forget this is our x is actually equal to this. Now at this point we were told that our x is actually a prime. So what we are going to be looking for now is what are the values of y that when we put it on this expression right here, it is actually going to give us a value of x that is going to be prime. And you discover that the only value of y that will satisfy this equation for our x to be a prime is y equal to, it's actually going to be y equal to plus or minus 1. So you can actually go ahead and check it out. For any value of y that is not plus or minus 1, you are not going to be having a value of x to be prime. You can check it out. Supposing you pick, let's say, y to be 2. If you put 2 here, 2 plus 1 is actually going to give you 3. And so 3 squared will give you 9. 9 plus 1 is 10. Okay, so if you come over here, 2. So we're having 10 on this side. So 2 minus 1 is 1. And then 1 squared is also 1. So 1 plus 1 will give us 2. So 2 times 10 here is actually going to give us 20, which is not a prime. So for any value of y you pick that is not plus 1 or minus 1, x is not going to be prime. And then if you look at this condition, they say that our x has to be prime. So y is equal to, has to be equal to plus or minus 1 for x to be prime. Okay, now when we can now get the values of x for when y is equal to, let's say, positive 1. Now we substitute here, our x is now going to be, if you put it here, 1 plus 1 squared, okay, plus 1, and that is this one. So we close this and we open the next one. So here we're now having 1 minus 1 squared, that is 1 minus 1 squared, and then plus the other one. So we close this, and then you're gonna be having that this is 2 squared plus 1, okay, and then we have 0 squared plus 1. So we're having that this is 4 plus 1, and that's going to give us 5, and then multiplied by 1, which is actually equal to 5. So we see that when our y is equal to 1, our x is actually going to be 5. Now let's now check for when let's find the value of x for when our y is equal to minus 1. So what we do is we write this, our x will now be equal to, so putting it right here, we have minus 1 plus 1, that's squared, and then plus the other one. We close this bracket, open the next one. So this is our minus 1 minus 1 squared plus 1. Okay, so that's what we're having. Of course, this one will give us 0 squared plus 1. Okay, and then the other bracket will give us 2 squared plus 1. And then of course you see that this is 1 times the other bracket, which is 5, and that's going to give us 5. So this is actually going to be giving us the solution. Therefore the solution set is, so for when our x is equal to 5, we have 5 comma 1, our y is 1, and then when our x is equal to 5 again, our y is equal to minus 1. So this is going to be the solution for this Diophantine problem right here. You can actually take any of them and put here. You are going to be having that it is going to satisfy this equation right here. You can check it out and let me have your thoughts in the comment section. And that's where we are going to be wrapping it up in this video. Make sure you give this video a thumb up, subscribe to our channel, and also turn on the notification icon so that whenever we release new content, you will actually get to know more about it. And of course, if you have any question or any challenge in solving this problem, you can also just put it in the comment box of this video, and I will sure address that. So thank you so much, and I'm going to see you guys in my next video. Bye.